Hello, everyone, and afternoon. Today I'll be just taking you through my presentation on water use efficiency trends and the effect of pre-harvest water stress on post-harvest fruit quality. What we know is that in agriculture, we largely depend on the limited water resource. As a result, there's reports that about 45% of that water that we have is lost. And knowing that and knowing our growing conditions, that we produce fruit outside the rainy season, and as a result, we depend on water that is on dams and rivers. And for that reason, we need then a strategic water allocation that will be based on known fruit water demand during our growing season. And that is very necessary to knowing that we are very much increasing the planting density of our fruit trees, as well as other yield enhancing factors. So my presentation today will be just outlined in three parts. Part A, I'll be just talking about water use efficiency and fruit growth dynamics of peckhams as well as forel pear orchards grown in different growing regions in the Western Cape. And secondly, I'll be focusing on the efficiency of irrigation timing, on the effect of irrigation timing as well as water stress on the physiology of the forel trees. And lastly, I'll be just talking about the post-harvest response of forel pears to the pre-harvest water stress, as well as the manipulation of timing in irrigation. First of all, we just wanted to quantify how much exactly water is used by the peckhams as well as forel trees. Now, to be able to quantify that water use, we then needed to measure how much water we put in, as we currently do, and also measure how much water in the soil as well as taken up by the tree using the sap flows, measure the stress levels using the pressure bomb, as well as at the tree level, measuring the stomatal conductance. And overall, within the orchard, we then measured the orchard evapotranspiration using the AD covariance. And for our research, we then selected two different microclimatic areas within the Western Cape, the Worsley area, as well as Sirius, classified by cold winters, and the EGVV area are classified by warm winters, at least for the trees. Now, we then measured the fruit growth during the season. And what we notice is that peckhams tends to grow very much faster compared to the forel. And that is just cultivar differences. But also that has implications in terms of the size that we get at the later stage when we harvest our fruit. But in terms of the peckhams, the forel had the largest canopy compared to the peckhams. Now, we then, with the help of dendrometers, we were able to measure early season the swelling as well as shrinkage of the fruit as well as the stem. What we noticed early season is that the fruit during the day tends to shrink, and that is due to the permeability of the skin of the fruitlet at that particular time, but it continues to grow or swells during the late afternoon as well as night. And we are seeing similar results in terms of the stems over the course of early in the season. But if you look at the early season, if you look at the late season, then the fruit reacts differently, where it continues to swell even during the day, and that is explained by the dominance of the phloem inflows, as well as the less permeability of the skin of the fruit. and the stem continues to follow the same or similar trend as early in the season. So that also can help in terms of managing your irrigation and as well as your your foliar spray applications. Now, if you want to have more reading on that, you can just take a look at that paper. What we wanted to know is how much water Peckhams are using as well as the Pharrells. What we noticed is that Pharrells tend to use more water, about 200 millimeters per season larger. But in terms of the water productivity, we noticed that the Pharrell tends to have at least a lower water productivity compared to the Peckhams. But in terms of the economic water productivity, it had a higher economic water productivity, which influenced the value of, which is influenced by the value of the crop. But that is a different story if you look at the Fearboom orchard, where we got a comparable amount in terms of the economic water productivity, which was influenced only by the amount of yields that we obtained in that orchard. And secondly, I'll be just taking you through the irrigation timing and water deficit on growth and yield of the Pharrell orchard, as we know that now that Pharrell tends to use more water compared to the Peckhams. Now, what we also know, just to give you a background, is that water movement in the tree is controlled by the water potential gradient, which is water moving from the highest water potential to the lower water potential region in the tree. Now, if you look, you have a scenario of a clean and not cloudy day and very sunny, and you measure your leaf water potential, you would have a bell-shaped graph that looks like that, which shows that early in the day, as well as late afternoon, your leaf water potential is very much high, and then midday, it drops. But if you put a xylem, then it also follows the similar trend, but then later in the day, it shows, during the day, it shows that there's a little bit less or higher water potential compared to the leaf, which then explains the water movement from the stem to the leaves. But if you put fruit then, which is going to help us in terms of allocating when exactly to irrigate, fruit shows highest dominance in terms of the water potential, early morning as well as late afternoon, which is water will then move from the stem from the stem directly to the fruit, and then that explains how your fruit then swells. And for that reason, we then wanted to know how much, at what time in the day we can be able to allocate our water. We've designed an irrigation strategy whereby we used the micro sprinklers as normal farm standard, applied about 70 liters per day, as well as its deficit, about 74% of the 32 liters applied. And we also looked at the drip, normal drip, applied early morning about 50 liters per day, as well as its deficit. But what we were then hypothesizing is, let's apply the same drip, but later in the day, as we know that the fruit, it tends to be the most dominant sink at that particular time of the day. So we used late drips to apply the same amount of water, but later in the day. Now, to be able to know exactly at what time during the day we apply that water, we then measured the Pharrell diurnal water potential, and as a result, we noticed that early in the season, the leaf water potential as well as the fruit water potential was very much comparable, and as a result, later in the day, the fruit was then mostly dominant in terms of acting as a dominant sink, and that also shows the relation of the fruit and the leaf, as well as your earlier foliar sprays. But the fruit tends to be the most dominant sink even later season, and this starts even early in the morning as well as late afternoon. And this change starts about around 25 of December. And we then propose that, okay, let's apply our water later in the afternoon because it's mostly the same scenario, even early season and late season. We also measured midday water stem water potential to see if our treatments are stressed or not. And early season as well as late season, we noticed that our treatments were showing a little bit of stress. And early season, that was only due to the low amounts of irrigation that were applied. And later in the season, that was only due to when we've already harvested our crop and the irrigation was stopped in the farm. But during the mid-season, almost all our treatments were very much not stressed. But however, the case was different in terms of the early morning drip deficit, which was showing more stress. Now, if you look at the average soil water content, it also shows that our drips overall during the season were very much stressed. And the case is just different in December, around 12th of December, when we had to ramp up because of the early season stress. We had to ramp up our irrigation. We also measured stomatal conductance to see if that's the case in terms of the stress that we're experiencing, we're seeing. And what we saw is that micro control, which is the normal farm standard, as well as our proposed irrigation timing, which is later drips applied later, we noticed that they were not very much stressed compared to the normal drip, which is applied early in the morning. And that justifies the timing of water application. We then measured the fruit growth over the course of the season, and we noticed that applying your water by drips late afternoon, it showed us very high fruit growth rate compared to the rest of the treatments, and applying your water through drips early in the morning tend to have the least growth, fruit growth. And the micros were just in between the two. In terms of the yield that we measured and later in the season, those results were very much translatable to what we were seeing in the orchard. And the normal drip applied later had the highest yields compared to the normal micro, and the drips applied early in the day. They had more stress. They had more stress, and they had the least yield. In terms of the numbers, that was the case as well, the fruit numbers. But if you look at the water use then, the micros were using a lot of water, and the drip applied early morning was using less water. And to translate that then to the water productivity, which is what we were interested in, if you can reduce the amount that you apply in Pharrell and still obtain the same yield that you want. And for that reason, we saw that if you reduce your irrigation at a certain up to a certain point, you can actually increase your water productivity, and that is just for only one season. Now I'm going to take you through the post-harvest defects as well as durability of the Pharrell pears in response to the pre-harvest water irrigation timing and water deficit. And that is the fruit that we harvested from our treatments that we are applying before, the part B. And we only focused on the outside fruit with interest of looking at the corky spot as well as mealiness. And for that, we did not see any corky spot in all of our treatments. But then if you look at the fruit quality, we try to harvest our fruit at the optimum maturity. In terms of the fruit, as I've mentioned before, that the drip control applied later was very much showing the highest fruit growth. But if you look at the firmness after shelf life, the most stressed drip, which is the drip deficit as well as the drip control applied early in the morning, was showing still high firmness at that particular time. To translate that to sensory mealiness measurements, we noticed that because of the high firmness of those, the drip deficit that were very much stressed, they had the least mealy fruit, and that is due to the firmness, but the most unstressed fruit had the highest sensory mealiness. And that we think that is due to the rate of fruit growth during the season, which drips were showing the least growth during the season. And this is then in support of the work that was reported by Muziri, that larger fruits have higher porosity as well as high mealiness. In terms of the quality of the color of the fruit, we noticed that the drip deficit, which was very much stressed, was showing more blush color. But that is due to the less observed growth in terms of shoot growth, vegetative growth in the orchard, as well as. But however, the same drip deficit applied later was showing very much a less blush. But that is of the similar range in terms of the commercial standard. Now, lastly, I will just, we noticed that the seasonal transpiration of the Farell orchard was high, about 7,000 cubic meters per hectare per season in Elgin as well as in Ceres. And we also saw similar canopy. There was no difference in terms of the canopies, but in terms of the pachyms, we noticed that the seasonal total transpiration was about 4,000, 4,000 as well as 5,000 in the Fearboom as well as Worsley, and those differences are also influenced by the canopy differences, which is the Worsley area had about 0.5 more canopy leaf area index than the Fearboom area, even though the Fearboom had the largest yields. Now, despite of high water use as well as low water productivity of the Farell, the economic water productivity was high because of the value of the Farell compared to the Peckhams. Now, if talking about the irrigation timing, trees under normal drip deficit, which is the one applied early morning, showed consistently stress throughout the season. Yet the water status of the drip deficit applied later in the afternoon was similar to that of the rest of the treatments, which then supports our hypothesis that it is really much possible to reduce the amount applied in the Farells and yet produce the same yields. Now, these differences in tree water status are translated to the observed yield that we were getting or we obtained. Now, in terms of the quality of the fruit, we noticed that fast fruit growth rate has a positive correlation to mealiness in the Farell. However, this should not alarm you, as you've heard the previous speakers, that there's measures that are done to be able to control mealiness even post storage, as well as keeping your your fruits for a longer period in storage. However, another season's data is worth looking at to be able to support what we are seeing in terms of the water use of the pharrells, as well as the pear cams, as well as the irrigation timing. But for now, we noticed that manipulating the time of applying your water really has a positive input in your water use of the pharrell trees. Okay. Yeah, I would like to just say thank you to everyone who supported the work.